prior to inspecting the statement, it's essential to initially comprehend the meaning of what is being examined. The Huge Hadron Collider (LHC), operated by CERN, represents an extraordinary accomplishment in science, spanning 17 miles. This immense organization of superconducting magnets isn't just the biggest, but also the most powerful atom smasher in existence. It stands as a great example of human inventiveness and scholarly advancement. Astoundingly, the LHC is so powerful that it can reproduce conditions similar to those present at the birth of the universe. Anyway, as we investigate the sweeping nature of the universe, one should ponder: could this machine, which plans to unlock the secrets of existence, accidentally expose us to unanticipated dangers? Established in 1954, CERN is one of the most prestigious scientific research organizations worldwide, comprising 23 member nations and a vast community of scientists. It functions as a hub for collaboration and advancement, and while the LHC is its lead project, it is only one part of an immense network of particle accelerators and experiments. Consider the LHC as a track not for vehicles or horses, but for subatomic particles competing in a race of speed, accuracy, and the actual fabric of spacetime. Inside the LHC, protons are accelerated to almost the speed of light, replicating the energy levels that existed at the time of the Big Bang. The subsequent impacts produce temperatures far higher than those found at the center of the Sun. A series of magnets directs the protons on their path, and advanced cooling systems maintain the magnets at temperatures lower than those found in space. These impacts occur at 4 specific points inside the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb gather data. Each of these detectors has a unique role, offering various perspectives on the outcomes of these collisions. Together, they function as gigantic cameras, capturing images of the results, with researchers analyzing the data to reveal elusive particles like the Higgs boson, often referred to as the God particle, and other anomalies that could help explain the building blocks of the universe. By focusing on the subatomic world, scientists hope to gain a deeper understanding of the universe. However, each new discovery tends to raise even more questions. The LHC isn't just a tool. It represents humanity's tireless curiosity and quest for knowledge. It symbolizes our drive to understand the forces that govern existence. However, as we push the boundaries of the unknown, we must also confront the moral and existential dilemmas that come with this pursuit. What risks could arise from probing too deeply into the unexplored? Could our quest for knowledge one day unleash powers beyond our control? At CERN, where the limits of human understanding are constantly tested, a disturbing realization has emerged, one that has unsettled even the most seasoned researchers. Brian Cox, a former CERN scientist and respected voice in particle physics, recently shared a disturbing statement that has caught the attention and concern of people worldwide. According to Cox, the goal of the LHC is to recreate a miniature version of the Big Bang. Yes, a small-scale recreation of the event that birthed our universe. Cox also explained the immense potential of the LHC for groundbreaking discoveries, such as shedding light on the puzzle of dark matter, a mysterious substance that makes up a large portion of the universe. The possibility of harnessing the fundamental forces of the universe is, of course, thrilling, but it carries inherent dangers. The miniature Big Bang is not merely a theoretical concept. It is a phenomenon that actually occurs within the LHC, where extreme heat, pressure, and energy are created, mimicking conditions from the very beginning of the universe. Perhaps we are witnessing the dawn of recorded history. However, with such immense power comes great responsibility. What if something goes wrong? This concern is not new. In 1978, Russian physicist Anatoly Borsky encountered an incident that would forever change his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Ingrada, Russia, a malfunction caused a proton beam to strike him. The beam, traveling at nearly impossible speeds, penetrated his skull, entering from the back and exiting through his nose. Despite the brilliance of the flash of light he experienced, which was brighter than 1,000 suns, he remained conscious and even walked to seek treatment. The aftermath of the incident was both remarkable and concerning. Borsky lost hearing in one ear and experienced partial facial paralysis. Despite the severity of the injury, his mental faculties remained unaffected, and he continued his scientific work. His experience serves as a stark reminder of the power and potential risks inherent in particle accelerators. The risks associated with a particle collider like the LHC should not be underestimated. There are real concerns about unforeseen reactions that could alter the very fabric of existence. Some scientists fear the LHC could create a tiny black hole. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. They are mysterious, terrifying forces lurking at the edges of the universe. The idea that the LHC could create even a small black hole is both fascinating and alarming. Could such a black hole grow uncontrollably, consuming the Earth from the inside out? CERN scientists have assured the public that any black hole formed would be extremely unstable and would dissipate instantly. Still, the remote possibility of such an event has sparked widespread debate and concern. To understand how the LHC could potentially create a black hole, we must first examine how particle accelerators work. When protons collide at near-light speeds, the energy released is so intense that it can warp the very fabric of spacetime. Imagine a trampoline stretched tight and then dropping a heavy object onto it. The fabric bends, and if the object is heavy enough, it could create a deep depression, pulling anything nearby into it. This simplified analogy gives us a glimpse of how the LHC could affect spacetime on a quantum scale. At this quantum level, where the laws of physics can seem strange and unpredictable, a theory has emerged suggesting the existence of extra dimensions beyond our familiar 3 dimensions of space and 1 of time. If these extra dimensions do exist, the LHC may be able to access them, potentially creating a gravitational well that could form a tiny black hole. The possibility of such an event has attracted attention from prominent physicists, including the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extremely high energies, potentially leading to catastrophic events like vacuum decay. Famous astrophysicist Sir Martin Rees also expressed concerns about the LHC's experiments in his book on humanity's future. He explored the potential risks presented by particle accelerators, particularly the possibility of vacuum instability. While he acknowledged the low likelihood of such an event, the risks remain a point of debate. Such an occasion happening, he underscored that even a little possibility justified serious thought. A lot is on the line, and the edge for blunder is razor dainty. Specialists at CERN have directed broad reenactments and investigations, playing it safe to guarantee the well-being of their investigations. Brian Cox himself has recognized the worries encompassing the LHC. However, he accentuates that tough safety measures are in place. These include far-reaching audits and conventions to guarantee that the collider works with the most extreme alert. As indicated by Cox, the energies associated with LHC tests are undeniably less than those that normally happen on the planet. Furthermore, the possibilities of making a stable dark opening are cosmically low. Even if one somehow managed to form, it would be so little and unsound that it would rapidly disappear, delivering an explosion of energy anticipated by Hawking's hypothesis of selling radiation. Some have hypothesized that the LHC tests could open an entryway to another universe or aspect. Despite the fact that this thought is generally excused by standard researchers, it has ignited the creative imagination of many, filling legends and reports. What lies beyond our universe? Might we at any point inadvertently release forces or substances that we don't fully grasp? The idea of equal aspects isn't new. String theory, a driving competitor for a unified theory of everything, suggests the chance of more than the 4 aspects we experience, 3 of space and 1 of time. These additional aspects might be stowed away from our insight, but under outrageous circumstances, they could hypothetically be accessed. Imagine the LHC as a key opening ways to domains that have stayed hidden since the dawn of history. When protons impact with energies previously unheard of on the planet, they could make swells that test these secret aspects. While this thought remains speculative, it highlights the charm of the unknown. The possibility of finding different aspects continues to dazzle the public, regardless of the reality that standard researchers remain doubtful about the LHC opening a passage to another universe or to hell itself. Still, the possibility of the LHC as a huge key opening new realities persists, sparking the imagination of many. So, should we be worried about the risks related to the LHC? It's easy to get caught up in electrifying headlines and fears of an inestimable catastrophe. Yet the truth is that researchers at CERN are well aware of the potential dangers. They have taken precautions to ensure the safety of their investigations and constantly monitor and evaluate their work with great diligence. The potential rewards of their research, such as uncovering the secrets of dark matter, finding new particles, and improving how we understand the universe, are truly remarkable. While these accomplishments represent a giant leap forward in human knowledge, they are not without risk. Like all great scientific progress, the LHC's investigations raise significant moral questions. Could the formation of intriguing particles or the investigation of high-energy conditions trigger outcomes we can't anticipate? These questions require careful reflection on the broader implications of scientific exploration. All in all, the Large Hadron Collider stands as a testament to human creativity and curiosity. It has already led to significant discoveries in particle physics, shedding light on the secrets of the universe. However, as we venture into these unfamiliar regions, we must remain vigilant and mindful of the risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, but it is not without its challenges. The LHC represents the frontier of scientific investigation, where theory meets experimentation and where the very foundations of our understanding of the universe are being tested. The journey of discovery is rarely without risk, and the LHC is no exception. It pushes the boundaries of physics, attempting to reconcile the fundamental forces of nature and answer long-standing questions about the origins of mass and the nature of dark matter. But as we explore these frontiers, we must also consider the moral and existential questions that arise from harnessing the forces of the universe. The risks of accidental outcomes, whether for our planet or the very fabric of space-time itself, remain a challenge that demands thoughtful consideration. Nevertheless, the pursuit of knowledge remains one of humanity's most noble endeavors, and the LHC's experiments, while dangerous, offer us a glimpse into the vast, unexplored realms of science that await discovery. As we stand on the threshold of revelation, the journey to unlock the universe's secrets requires both ambition and caution. The LHC represents not just the pinnacle of human technological achievement but also an extraordinary resource that could reshape how we understand everything, from the smallest particles to the largest cosmic phenomena. Each advancement opens new questions, leading us down new paths of investigation. However, the journey of scientific discovery, laden with uncertainty, holds the promise of revelations that could redefine how we understand the universe, our place in it, and the very laws that govern it. One of the most significant aspects of the LHC's tests lies at the intersection of theory and reality. For years, physicists have struggled to unify the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The hope has always been to reconcile these forces into a single framework, one theory that explains everything. The LHC has played a vital role in providing experimental proof and insights that bring us closer to this elusive goal. Its work not only advances our understanding of particle physics but also holds the key to uncovering the fundamental secrets of existence itself. The moral dilemmas associated with such trials are profound, but the pursuit of knowledge has always been accompanied by risks. When those risks involve altering the very fabric of reality, however, the stakes become much higher. Could an experiment at the LHC inadvertently trigger a phenomenon we don't yet understand, leading to unpredictable consequences? This question continues to be pondered by scientists, philosophers, and ethicists alike. As we venture into these strange domains, we must carefully consider the responsibility that comes with wielding such immense power. Yet few would argue that the pursuit of scientific progress is not worth the risk. The rewards, new technologies, medical breakthroughs, and an expanded understanding of the universe, are immense. The discoveries made by the LHC so far have already transformed the scientific landscape, from identifying the Higgs boson to advancing our understanding of dark matter. These breakthroughs have far-reaching implications for physics and numerous other fields that rely on this fundamental knowledge. As we continue to push the boundaries of what is possible, the LHC serves as a reminder that science is never free of uncertainties. No experiment is entirely without risk, And the LHC, as magnificent and powerful as it is no exception. But with each risk comes the potential for great discoveries. The LHC is a symbol of humanity's unwavering quest for knowledge, driven by the desire to understand the universe, explore the depths of reality, and uncover the forces that govern everything, from the smallest particles to the largest galaxies. It may carry risks, but it also represents the zenith of human achievement in the realm of particle physics, an instrument that allows us to probe the deepest questions of existence, challenge the laws of nature, and seek answers to the mysteries that have eluded us for centuries. Whether the LHC will ultimately unlock new dimensions, open doors to parallel universes, or trigger unforeseen phenomena remains uncertain. However, we do know that it is one of the most powerful tools ever created, capable of uncovering secrets about the universe that were once thought to be beyond our reach. The potential for discovery is boundless, and as we continue to venture further into the unknown, we are reminded that science is a journey, one that requires both courage and responsibility. As the tests at CERN progress, we must stay mindful of the potential outcomes, risks, and complex possibilities for new understanding that lie ahead. The LHC, while representing the cutting edge of modern science, is also a reflection of our deeper search for meaning and consciousness in an immense and mysterious universe. Each new discovery brings us closer to a fuller understanding of the forces that shape our reality.